All right, in this video, we're going to look at the answers and point values for AP Practice Problem B. In AP Practice Problem B, they give us two functions. One is g, which they give us a picture of. They define g on the closed interval from -4 to 8, but we can see that from the picture that it's defined for all values on that closed interval. They also let us know, just to be sure that our calculations are accurate, that this is a straight line, this is a straight line, that this is a semicircle. It's good to note the semicircle is under the x-axis because they're asked about integrals. We'll get some positive areas, but this will come out as a negative area. And I said two functions, so that's the first function. The second function they sneak on here is f of x. They define f of x to be 3 times x plus the integral from 0 to x of g of t dt. So t is just a dummy variable. 0 to x is basically representing this area. The integral from 0 to x of g of t dt is the area under the curve, between the curve and the x-axis of g. So whatever x value is in here, we're going to put it as the upper limit and get that area. So this function not only triples the x value, but uses that x value to get an area off of the graph we already have. Part A now, to start answering the questions. Part A asks us to evaluate f of 7 and f prime of 7. So in order to get f prime of 7, it'd be nice to have f prime in general. So I calculate f prime of x right over here. How do I get that? How do I get this as an answer? Well, f prime is going to be the derivative. That means I need to do the derivative of these two pieces. 3x's derivative is 3. And you have to remember, when you take the derivative of an integral, derivatives and integrals are inverses of each other. Taking the derivative of the integral cancels them. It basically throws this little x in for the dummy variable. So the derivative of the integral just gives you the function itself, and the function itself is just g of x. All right, so the derivative of this whole thing is 3 plus g of x. So now we can evaluate f of 7 and f prime of 7. F of 7 is actually the more annoying one, because if we go to plug in f of 7, we get 3 times 7, and then we have to do the integral from 0 to 7 of function g, which is what I wrote here. 3 times 7 is 21. I need the area from 0 to 7 of that g function. I got these two values. Here's how I got them. To integrate from 0 to 7, I'm basically getting the area of this semicircle. And then as I jump over 7, this is got a discontinuity in it, but basically I still get area under the section up here. So the section from 0 to 6 is the semicircle. 6 to 7 is this rectangle. This rectangle is easy to get because it's 3 by 1. So that's how I'm getting that area. The other part of the area is from 0 to 6. Well, basically this is a semicircle. I want to consider the whole circle at first. If it was a whole circle, it would have a radius 3. Area of a circle is pi r squared, so it would be pi 3 squared, which is 9 pi. Now the whole circle would be 9 pi. I only have half the circle, so I basically have to cut that in half, which is 4.5 pi, or you could say 9 halves pi. But the other tricky thing is realize that this area is actually under the x-axis. So as the curve is negative, this is accumulating essentially negative area. So that's why I have to count this as negative. So what is f of 7? It's the 3 times 7, which is 21, plus that area I just found, the area under the semicircle, plus that extra little rectangle, and add these together for a grand total of 24 minus 4.5 pi. That gets you a point. F prime of 7 is actually a little easier because f prime is easier to evaluate. It's 3 plus g of x. So f prime of 7 is 3 plus g of 7, and g of 7 is just the y value at 7, which is 3. So this value is also 3. 3 plus 3 is 6. There's my second point. Part B then wants us to find on this closed interval from -4 to 3, it wants us to find where f attains a maximum value. So if a function is continuous on this interval, which this function should be, because basically there's an area everywhere, and 3x has always got values. So there's nowhere we're not getting an area, nowhere we're not getting a 3x value. So this thing is a continuous function, so the extreme value theorem applies. Basically, the extreme value theorem says that a maximum will occur. Where will it happen? If you're continuous on a closed interval, your absolute max or min have to exist, and they have to happen either at the endpoints of your interval or at critical values, because normally maxes and mins occur possibly occur at critical values. But since we're artificially cutting it off, it's possibly happen at the endpoints. So that's basically the extreme value theorem in a nutshell. It tells us what we have to check. If we want to look for maxes or mins, we have to check the endpoints or critical values. So remember, critical values are spots where the function's derivative is either 0 or undefined. So just first talk about, are there any spots where the function's derivative is undefined? Function f, here's f's derivative. Well, g's always defined, and 3 is always 3. So f prime of x is never going to be undefined. So in order to look for critical spots, we just know where f prime of x could be 0. So that's what I solved here. I basically said, well, if I'm looking for critical values, they need to happen where f's derivative is 0. How am I going to find where that happens? Well, I'm going to use the fact that f's derivative is actually 3 plus g of x. So if I can find where that equals 0, well, where's that equals 0? Well, move the 3 over. It happens where g of x equals negative 3. And how do I know that that's the x value 3? Well, if you go back up to g, where is g's y value negative 3? Well, it only happens one time. It's at the bottom of the semicircle. So g's y value is negative 3 at x equals 3. So if you follow the chain backwards, x equals 3 makes that negative 3, which makes this 0, which makes this 0, which makes it a critical point for this function. What's nice, though, is this critical value is also an endpoint. So the extreme values theorem said check the endpoints and the critical values, but since they're one and the same, I just have to check the function values of the endpoints. So one of the endpoints is the max that I'm looking for. So let me check them both and see which one's bigger, and that'll be the maximum. So I checked them down here. I need to check, now in the original function, I need to get their y values to see which one's greater. I need to check f of negative 4 and f of 3. Well, I have to plug them into that f function, which was f of x was 3 times x plus integral of 0 to x of g of t dt. If I plug negative 4 in, I'm going to get negative 12. Now I'm going to get the integral from 0 to negative 4. We don't like when the integral's backwards like this. I'd rather go from left to right instead of right to left. So to switch these, I'm allowed to switch the limits of integration so long as I change the sign on this. So that's what I did. So I made it negative 4 to 0 and changed that plus sign to a minus sign. So now 3 times negative 4 is 12. The plus sign became a minus sign. I'm now integrating from negative 4 to 0 of that g function. This value in here, this integral is 4. It's basically, if I go back and look at the function from negative 4 to 0, that's this triangle here. And the area of this triangle is 1/2 base times height, which is 1/2 2 times 4, which comes out as 4. All right, so that's how I'm getting this value. So basically it's negative 12 minus 4. Negative 12 minus 4 is negative 16. The other value is that critical point slash endpoint. What's f of 3? Well, it's 3 times 3 is 9, plus the integral from 0 to 3 of g of t dt. So now I have to go back up and look at what's the area from 0 to 3. It's negative 2.25 pi, but how do I know that? Well, the area from 0 to 3 is this quarter circle. We already know this area of the semicircle is negative 4.5 pi, so cut that in half, and you get negative 2.25 pi. So plugging them in, 3 times 3 is 9, and now I'm going to add that negative, or essentially subtract 2.25 pi. And 2.25 pi is not bigger than 9. In fact, you can see that in the problem, because if you actually look at this semicircle, you can actually see here's an area of 9 right here. And, sorry, the quarter circle doesn't quite make up 9 units. You could also, if you have a calculator, figure that out. But basically, I knew that when I added these, this wasn't big enough to cancel out the 9 to go negative. So this is going to be positive. So since this was negative and this is positive, this is the absolute maximum. So the absolute maximum is approximately 1.93. It occurs at x equals 3. So point values on this, so that's a lot of explanation. The point values was, one of them was recognizing the critical value, saying the derivative equal to 0. The other point came from recognizing and showing some explanation for why x equals 3 would be where the maximum occurs on that closed interval. All right, so let's look at C. C is a bit easier if you just understand what it's asking. It wants the limit as you approach 0 from the left of g prime of x, limit as you approach 0 from the right of g prime of x. So we have to think of what's g prime of x, because they didn't really tell us that. We have f and we have f prime. We haven't talked about g prime. Now, we don't need to know exactly what g prime is analytically, because we have a picture of it. G prime graphically is the slopes. So basically they want to know what's happening to the slopes of that function, because that's what g prime represents. What happens to the slopes as we approach 0 from the left and 0 from the right? Well, the slopes as I approach 0 from the left, if I look at all these slopes, the slopes are constant. These slopes are down 1 over 2, or right 2. They're negative 1/2 slopes. This negative 1/2 slope continues all the way as we get closer and closer to 0. So the slope limit from the left is this negative 1/2. The slope limit from the right is a different value, because now we're following this curve. This has a bunch of negative slopes, but they're getting negative and steeper and steeper and steeper, and at this point they want to go vertical. Vertical slopes are undefined, because basically at this spot, if you think of the tangent line as we get closer to 0, we're getting pretty steep, and if you're infinitely steep, you basically are like going up however many and over 0, and division by 0 is undefined. So the slope on the left side is at 1/2, and the slope on the right side is approaching being essentially infinite, or undefined is the better term, because infinity is not really a number. So as we look at these, they just give you 1 point for each answer, but it's basically you can obtain them graphically. This answer is negative 1/2, and this answer basically says if it doesn't exist. Infinity is an answer, but it tells us a way it doesn't exist, right? Infinity is telling us it doesn't exist in a particular way. So you can just say DNE in this case, right? It doesn't exist because it's essentially getting larger and larger without bound. Or I should say it's getting negatively larger. It's actually getting, going toward negative infinity. All right, so those are the two answers for that. And then the last one is a reasonably challenging question as well, because it's finding this limit, and they don't let you get away easy on it, because basically you're going to need to use L'Hopital's rule and evaluate the function yet again. So if you want to evaluate a limit, the first thing to do is to just try to plug it in. So we can see, do we get some kind of value from this? Well, if I plug in -2 to see if the function value will give it to me, I get f of -2 plus 7 and e to the 3 times -2 plus 6, all up there, minus 1. What's this calculate out to be? Well, the bottom is easier, because 3 times -2 is -6. -6 plus 6 is 0, and e to the 0 would be 1, and 1 minus 1 is 0. So the bottom is 0, so that's already given us trouble. But the top also comes out 0, because what's f of -2? Well, I calculated that over here. F of -2 is 3 times -2 plus the integral from 0 to -2 of g of t dt. I swapped these to make it a minus sign, and I went up to the picture to get what is the area from -2 to 0. The area from -2 to 0 is this triangle, which basically has a base of 2, height of 1, 1/2, 2 times 1 is 1. So basically I'm also, since I swapped them, I'm subtracting that 1. So I get -6 minus 1, which is -7. Not a big surprise, because they want this question to be more difficult. So big surprise, that comes out as -7, and -7 plus 7 is 0. So you get 0 over 0. Now, if the limit comes out as 0 over 0, that doesn't mean the limit doesn't exist. It means this is called indeterminate form. It means we can't determine the limit from this. We're not sure what it is. So that's where L'Hopital's rule comes in. If you have 0 over 0 or infinity over infinity, you can use L'Hopital's rule to evaluate the limit, or try to. L'Hopital's rule basically says if you have this indeterminate function, basically, or indeterminate fraction, if you take the derivative of its top and derivative of its bottom, that new expression will have, if you do this, the limit to that, it'll have the same value as this limit. So that's what we'll do, is use L'Hopital's rule. So I need to do the derivative of the top and derivative of the bottom and retry the limit. How do I get the derivative of the top? Let's go back to the original with the x's in it. Derivative of the top, well, f's derivative is literally f prime. 7's derivative is 0, so that's why I didn't write it. E to the 3x plus 6's derivative. Remember, e to something is its own derivative, but we have to do the chain rule. So e to the 3x plus 6's derivative is e to the 3x plus 6 times the derivative of the inside. The derivative of the inside is the 3x plus 6's derivative, which is 3. So I get this 3e to the 3x plus 6. So that's using L'Hopital's rule. This is the derivative of the top, derivative of the bottom. I'm going to retry the limit and plug it in. Now this time it works. I'm going to plug in that -2. F prime of -2 I need to get. And when I plug -2 into this, we already saw this comes out, e to this power comes out as 1. And then 3 times 1 is 3. So what's f prime of -2? Well, we have the expression for f prime. F prime of -2 is 3 plus g of -2. G of -2 is 1. So we're basically getting 3 plus 1, and that's how I'm getting this value 4, because basically this derivative works out to be 3 plus the value of what was it? I just said g at -2, which was basically it comes out as 4. It's 3 plus 1 is 4. So we have 4 over 3, and that gets us all the points. Let me tell you where they come from. A point comes from recognizing that this is indeterminate form. Another point comes from applying L'Hopital's rule, at least the derivative part correctly, and then finishing L'Hopital's rule by showing the plug-in. So even though this was indeterminate, L'Hopital's rule says, well, since this expression had limit of 4 over 3, this original expression also must have the limit of 4 over 3. And that'll get us all the answers and all the points, all right? So this one is a bit difficult. Well, it's a little long, but it's good to practice. It's, the 3 big modes on the AP exam are analytic functions, graphs, and tables. And notice this one has a graph, an analytic function that includes an integral in it. So there's a lot to see in this problem. And they also somehow incorporated L'Hopital's rule and some limit questions in here too. And the extreme value theorem. So they hit a lot of concepts with this. All right, so even though it's kind of a difficult problem, it's a good problem to look through because of all the different concepts that it tests. Typical AP fare. All right, so that should do it for this. Be on the lookout for the video for AP practice problem C.